Good afternoon, Algebra Apps. This is today's podcast or screencast, if you will, on 3.3 angles of polygons. In the last section we had talked about angles and triangles, and we're going to expand a little bit on that and go to polygons. Now, if you look at the prefix of this word polygon, it's poly means many. So when we're talking about a polygon, we're talking about a shape that has three or more sides. Okay, and when we're talking about angles, you guys should have a good grasp of angles by now. But an angle is just what is created when two lines meet. Okay, it's the number of degrees between those two lines, and it's the same no matter where you go between those two lines. That angle is the same. So we're going to be looking at angles of many-sided shapes. And you'll start to see a pattern today, and I think you'll catch on rather quick. First, in your notes, make sure you have your name and date and chapter and section title. And then you'll see by the learning target has a few fill-in-the-blanks there that I want you to be able to do by the end of this section. It says by the end of the section I can find the, if you look at our essential question here, what I want you to be able to do is find the sum of the interior angle measures, so the angles on the inside of our polygons, and also the sum of the exterior angles, so the angles that are formed on the outside of our polygons. Okay, and then you'll see next on your notes it says for activity 1 refer to the back of the page. So I'll go through activity 1 here on the board, and you can follow along on the back side of your notes. And if you take a look at the directions there, what they're looking for, they want to know what polygon it is. So they're looking for the name of this polygon, first thing. And then they want to know how many sides does it have? And then they also want to know what's the interior angle measures. What's the sum of them? So when you add these four angles together, what should you come up with? Okay. Well, the very first thing that I can tell about this shape is that it has four sides. So anybody remember what a four-sided shape is called? Well, if you said quadrilateral, you are correct. Quad meaning four. Okay, quad meaning four. The next thing you had to do was say how many sides it has. You can see pretty easily it has four sides. And then lastly, what you had to do is you have to say what is the sum of the interior angle measures. So when I add my four angles together, what should I come up with? Well, the way that we know, the way that we're going to be able to tell how many what the sum of our measures is actually by using triangles. So from what we did last section, that's going to help us this section. And what we're going to do, first off, is see how many triangles we can split our shapes into. In this first one, it's pretty evident that you could only split it one way. Well, you could split it a couple different ways, but when you split it, you could only create two triangles. Here's one triangle right here, and here's another one right here. And what we know about triangles is that they have three angles. There are my three angles. And that when I add those angles together, I should come up with 180 degrees. Okay, that's the total amount in a triangle of degrees. Now, realize that I have two triangles right here. I'll outline the first one in green, and then the second one in blue. So if I were to add these up, I'd have 180 degrees in the green triangle and also 180 degrees in the blue triangle, giving me a total then of 360 degrees for a quadrilateral. Every quadrilateral? Yes. Every single quadrilateral, four-sided shape, has an interior measure. The sum of these four angles, 1, 2, 3, 4, adds up to 360 degrees. Okay. What I would like you to do now is to pause this video and to try letters B through E then. And if you want to work on this with your table partner, you can. If you want to work on it alone, that's fine. But see if you can recall what type of polygon it is, what the polygon's name is, how many sides it has, and then see how many triangles you can split your shapes up into to figure out your total number of degrees on the inside of that polygon. Okay, hopefully you have tried B through E. I will put the answers up here so that you have them and you know for sure. Letter B is a pentagon. 5 sides. It has 5 sides. And if you look at a pentagon, you can split it into a triangle. There's one triangle. There's another triangle. So I have one triangle in the middle. And I have a triangle on this bottom right side. And I also have a triangle on the top left here. So a pentagon can be split into 3 triangles. So to find my total number of degrees then, I'd take 180 plus 180 plus 180 to come up with a total number of degrees for a pentagon would be 540 degrees. For every pentagon, Mr. Gillis? Yes, for every single pentagon. Okay, and you should have done the same for letters C, D, and E. Letter C is a hexagon, 6 sides, and a total measure of 720 degrees. Letter D goes to 7 sides, which is a heptagon. Heptagon. And for a total measure of 900 degrees, these angles, 1, 2, 3, 4, 5, 6, 7, total interior angle measure here would be 900 degrees. And then lastly, letter E. You should all know this one very well. An octagon, looks like a stop sign, has 8 sides. Octagon. And octagons have a total measure of 1080 degrees. Okay, so make sure you have that then on your activity 1 on the back side of your notes. And also flip over to see that there is a letter F, and it just gives you a nice chart there to lay out your shapes. This could be helpful in the future to use this as a reference on the back side of your activity 1 page. When you have that complete, next up we'll flash back to the front side of our notes is a few vocab terms. Might be helpful to draw the shape along with the vocab terms. The first vocab term is convex. It says a polygon is convex when every line segment connecting any 2 vertices lies entirely inside the polygon. Now, it might not make a whole lot of sense right now until you compare it with its opposite. So once you get that definition down, just let's also take a look at the opposite of what a convex polygon is. The opposite of a convex is a concave. And it says a polygon is concave when at least one line segment connecting any 2 vertices lies outside the polygon. Okay, so remember a vertice is another way to say corner. So it's saying if I had, for example, this corner and this corner, where those line segments meet, if I can draw at least one line between them, and my shape has segments, has line segments that are in there, inside this polygon, or I can draw this line that's outside of that polygon, and I have a concave shape. The other easier way, sometimes that students remember this, is that this shape itself looks like a cave. Okay, maybe you're walking along right here. You might have to turn your head a little bit here, and you are pretending you're walking into a cave. Right, here's a little fire in your cave. Okay, so that's another way to think about it. Concave. I mean, really think about it as a cave. The opposite is convex. Every line segment connecting two vertices is inside the polygon. Here, this green one, line segment that we could drew from this vertice to this vertice, from this corner to this corner, is on the outside of this shape. Please make sure you have those two drawings and definitions down, and we'll move on to our key idea. This is going to be very helpful for you, and it will make your homework rather quick once you get the hang of this. It says the sum S of the interior angle measures of a polygon with n sides. So that n sides is just saying you don't know how many sides you have yet, is S equals n minus 2 times 180. So when you see this n right here, all that's telling you to do is to plug in the number of sides your shape has. Again, it might be a little confusing right now. Don't worry about it. Once I go through a few examples, I think it'll become a little bit more clear to you. All right, let's move on to that first example. It says find the sum of the interior angle measures of the school crossing sign. So it wants us to find the sum, so the total when we add together the interior angle measures of the school crossing sign. Well, to do that, go right back to your key idea. It says to find the sum of those interior angle measures, all you have to do is to use this equation. The sum equals the number of sides. So do I know my number of sides? Let's count on this school sign. 1, 2, 3, 4, 5. Okay, so I have 5 sides minus 2 times 180. Okay, I'm going to do my parentheses first. That's what PEMDAS says to do. That's 5 minus 2 is 3. And then I still have to multiply by 180. Okay, 180 times 3. 0 times 3 is 0. 8 times 3 is 24. Carry my 2. 3, 4, 5. So, I get S equals 540 degrees. And that's my answer. Took my number of sides, subtracted 2, multiplied by 180. And this shape had 5 sides. Go back to your activity 1. When we had a pentagon, a 5-sided shape, did that match up? Does that also have 540 degrees? The answer is yes, it did. Okay, so all pentagons do have that 540 degree interior angle measure. I'm winding down here on time, so I'm going to pause this video and continue it later with the rest of our examples. I think we've got example 2 and a little vocab and a key idea and example 4 left. Well, you shall be right back. Alright, I am back, and we are now on to example 2, where our directions tell us that we need to find the value of x. First, let's take a look at the polygon and see what I know about it. Looks like it's got 1, 2, 3, 4, 5, 6, 7 sides. So knowing that, should I be able to find out the total measure of the interior angles of this shape? Well, I just found out that the sum equals the number of sides, so 7, minus 2, times 180. Okay, so S equals 7 minus 2 gives me 5 times 180. And 5 times 180 should give me 900 degrees. So this is what the total of my 7-sided shape should add up to. Well, looks like I'm missing one of my values right here. So how could I find that value? One way would be to add up the values that I do know. I know 6 of them. Oh, sorry if you heard the bell in the background there. And subtract that total from 900. Okay, so if I add, I'll start at 128 and then work my way around this direction and add those numbers. I could actually write an equation here. 128 plus 130 plus 120 plus 115 plus 145 plus 140 and also plus x. All those added up together have to equal 900 degrees. If you take those numbers and add them together, those like terms, they are all constants besides the x, besides the variable. So adding just my numbers together should get a total of 778 degrees plus x. I haven't combined that with anything yet. Must equal 900 degrees. I think you guys are already starting to see the answer. Just subtract 778 from both sides of my equation, and x will equal 122 degrees. Okay, and we could find that out just by knowing that the sum of a heptagon, a 7-sided shape, is 900 degrees. Okay. There are a few on your own problems on page 121 that I would encourage you to try, and you can put those on the back of your example 1 paper. There's some blank space on the back there. And pause this video now if you're going to do that, because I'll give you the answers. Alright, for the on your owns, it was numbers 3, 4, and 5. For number 3, you should have gotten 105. For number 4, you should have gotten 75. And for number 5, you should have gotten 35. Hopefully, you got those answers. If not, feel free to ask me. I can help you out. Alright, we're going to move on to another definition, rather short one. Just kind of more informational than anything else, letting you know that a regular polygon has sides that are congruent and also interior angles that are congruent. So all of the sides are the same. Usually that's marked with these hashes on the sides. And also the angles are the same. So all of these angles are the same. They are congruent to each other. So in this case, we know that each angle has to be 60 degrees. 60, 60, 60. Because if they're all the same, there's only one possibility, because we know that a triangle has a total interior measure angle of 180 degrees. Yeah, so that's a regular polygon. It's a regular polygon. Here's our second key idea. And then we'll end with one more example. We talk about the exterior angle measures. So now we're talking about if you have shape say it's a triangle, you also have exterior angles formed when you extend these lines. Okay, so I could extend there, I could extend here, could extend here. There's angles formed on the outside of your shape. Okay, and that refers to the exterior angles. And this rule, this key idea, tells us that the sum of those exterior angles always equals 360 degrees. Always. Okay, in this case, it would just be y plus x, w plus x plus y, since it's just a triangle. But if you had a four-sided shape, it would be the same thing. Okay, you can extend each one of these sides, and you create angles that are on the outside of your shapes, of your polygons. Okay, it's a little bit more confusing to grasp, but once we try an example, we'll see if that makes a little bit more sense. Let's take a look. Example 4 says, find the measures of the exterior angles. Okay, so we are given 127, we are given 50, we are given x, and we are given 91. Okay, and our rule from our key idea tells us that when we add these four together, our total should equal 360 degrees. Okay, well, let's see if we can write an equation with that. 127 plus what other angle do I know? I know I have 50. Plus what other angle? I've got x. And also plus 91. All those added together should equal 360 degrees. Guys, oftentimes this can be the trickiest part, is writing this initial equation. Next up, taking a look at this equation, I have some like terms. 127, 50, and 91 are all constants. They are all just numbers. When I add them together, I come up with a total of 268. Plus x, I'm just bringing this down because I didn't add it to anything, has to equal 360 degrees. Now we have a simple equation. Split it at the equal sign. Subtract 268 from each side, and you'll be left with x. You should get, hopefully, 92. All right. Let's take a look. Does x look like it's 92? Does it look close to a right angle? Yeah, it actually looks really close to a right angle. Remember, right angles are 90 degrees. In this case, 92 degrees. Okay. That is all I've got for notes and examples for section 3.3. Thanks for participating. If you do have any further questions, or you're still confused, or you think Sal Khan could explain a little bit better, be sure to check out a Khan Academy video. Here is the link. Feel free to do that now, or at another time at home, or if you're having some issues with your homework, again, come see me. Nice job, and we'll see you later. Gillis out.